Good afternoon, everyone. Really happy to see you all in person here at Vegas. I'm Shaki Hali. I'm a senior product manager with S3, and I'm joined by Rob Wilson, who's a senior manager of product management with S3, and then also by Robin Anil, who's a director of research and technology with Bridgewater Associates. And we're super excited to talk about best practices for managing S3 data at scale. So in terms of agenda, we begin with an overview of S3, and then we are going to take a use case-based approach to talk through this session. So I will cover use cases on securing your data at scale and how to access your data archives. And then Rob will take over and walk us through monitoring your access logs, and then talking through managing your storage spend using features like inventory, lifecycle, and storage lengths. And then we'll hand over to Robin, who will walk us through a real-time customer use case for Bridgewater Associates and how they're using S3 features to manage petabytes of data at scale. And then we'll follow with a recap with Rob. So let's get started with an overview of Amazon S3. So Amazon S3 is the object storage that gives you virtually unlimited scale, helping you grow your business without being concerned about managing your infrastructure to support your data at scale. So customers often store millions and billions of objects in their S3 buckets. And we operate in 30 regions and 96 availability zones. We are also designed to offer 11 nines of durability for your data storage. Increasingly, customers are transitioning all their applications to the cloud, while some are just starting ground up in the cloud. And as a result of this shift, more and more customer workloads are moving to Amazon S3. Customers are choosing Amazon S3 for a variety of different reasons. For some, it is about the high availability, high durability across multiple regions, using features like cross-region replication, RTC, multi-region access points. For some customers, it's the cost optimization capabilities that we offer, like intelligent tiering and storage lengths. And for certain customers, it's the security features that we offer that help you control your access all from the bucket level down to the object level. And in this session today, we're going to talk about best practices and some of the latest tools that S3 offers that will help you automate the management of your data at scale. And we think that these tools will help you better understand, optimize, and perform actions across your ever-growing storage at scale. But before that, just wanted to thank all our customers who trust S3 to store exabytes of data and trillions of objects. So let's dive into the first use case. So the first use case is about encrypting your data at scale. But before that, I want to talk about Amazon S3 encryption support features. So here's a network diagram where you have the client and the bucket. And in S3, we offer three kinds of encryption. The first is the client-side encryption, where you are encrypting your data before it is uploaded to S3. And S3 offers AWS encryption SDK for your clients to automatically manage that. Second is encryption in transit, where you can encrypt your data over the wire using HTTPS and TLS. You can enforce this at the bucket level, where all your data that is being uploaded to your bucket will enforce encryption in transit. And lastly, we have encryption at rest, which offers three encryption keys. The first is SSE S3, which is Amazon S3 managed keys, where you outsource the encryption key management to us. The second is SSE KMS, where your keys are stored within an HSM, which is managed by AWS Key Management Service. Using these keys, you can control the access to your keys, control the rotation for your keys. And the last option is customer-provided keys, also known as SSEC, where you are providing the keys at upload and download, and probably you're managing those keys in your own on-premise systems. So with that, I want to talk about Amazon S3 feature. This is a feature that we highly recommend, which is a simple bucket level setting that mandates mandates all your encryption uploads in a bucket are being encrypted by default. You can choose SSE S3 or SSE KMS as your default encryption at rest setting. And it can be used for applications that do not support specifying encryption for each and every data upload. So let's talk through the first use case. Let's say you are operating a data lake in S3 that supports millions and billions of objects with petabytes of data. And you get a call from your cloud security lead for a meeting where he's asking for a compliance report proving that all your objects are encrypted, both that exist today and those that will be uploaded in your bucket in the future. So we spoke about default encryption feature that will take care of your future uploads in the bucket. But we should also focus on encrypting your existing objects. And we'll look at features like S3 inventory and S3 batch operations to do that. So like I said, the approach is to ensure that your future uploads are taken care of using default encryption. And we'll look at features like storage length, inventory, and S3 batch operations to encrypt your existing objects. So storage length is a tool that gives you organization-wide visibility into your object storage. And Rob will walk us through in detail about this feature, but for this specific use case, we can focus in on our regional distribution and see that about 26% of our storage in the US West region is unencrypted. So probably you want to focus on that region's buckets to encrypt your data first. So once we've identified the region and the buckets that we want to focus on, we can learn how to use a combination of inventory, Athena, and batch operation capabilities to create encrypted copies of your existing data. And as customers grow their data within S3, they want an easy and automated way to understand what objects in a bucket exist and how they can audit them. And Amazon S3 inventory is a great way to do that. So let's create an inventory report here that will indicate the encryption status of your objects. So first we'll need to create an inventory report in the management tab where we'll choose the inventory report. And now we are able to define the details for this of our inventory report, and we will give it a descriptive name. In the second screenshot, you can see that you will be able to define if this report will be stored or for our situation, we can select like an existing bucket where this report should be stored. And then we'll define if this report should like run on a daily or a weekly basis and choose the output file format, which can be CSV or a manifest file. Next, we will look at what are the metadata fields we want to include in this inventory report. So we would like to include the encryption status of your objects to indicate whether your objects are encrypted or not. So now we can create our new inventory report and wait for it to complete its execution. Now once the inventory report has been generated, we can input this report into Athena and write a SQL query, as you can see on the screen, to filter rows of objects that are not encrypted, because we want to focus on objects that are not encrypted. Now once we have created that report, we will input this file into S3 batch operations to create the encrypted copies of these objects that were identified as not encrypted in the previous section. So S3 batch operations, it provides a very scalable way to execute many tasks across millions and billions of objects. And because it's a managed service that runs in the background, it will manage your performance behind the scenes. You don't have to write any code or set up any server fleets or figure out like how to partition the work and distribute it to the fleet. It will just take care of all of these tasks on itself. So here is how it works. You first provide an input file that we generated in the previous step into the job, which could be a CSV or an inventory report. And next, you can select the operation you want to perform, which can be a copy, a lambda function invocation, object lock retention, etc. But in this specific case, we will focus on copy because we want to create encrypted copies of our object. And then lastly, you sort of determine how you want to view the results through the completion report or the job notifications. And here we see a deeper view of how a batch operations job will look like. So you will note the selection of the operation, the manifest, and the reporting location. And the priority also allows S3 batch operations to run multiple tasks in parallel so that you can set priorities across those. And so with this, we have satisfied our requirements and encrypted all objects in the bucket to be encrypted. To summarize, you can use storage lens to identify which buckets need to be focused on for your unencrypted data sets. And then you can use default encryption to ensure all of your future data sets are being encrypted by default. And then you can enable inventory report to identify objects that are not encrypted, and then use Athena to sort of filter on the non-encrypted objects, and then input into the batch operations process to create encrypted copies of those objects. Next, we'll talk about archiving your workloads. So before I talk about in detail on how to archive your workloads, I want to go into why customers want to archive their workloads. And there are three primary reasons for that. So the first one is that they want to achieve the lowest cost for their storage, right? And then the second one is they want to use it as a backup storage to improve the durability and the resilience of their primary data storage to fall back on their backup. And lastly, there are often situations where they have to meet their security and compliance requirements for their organizational data storage policies. And that's why they choose to archive it based on certain requirements. And to serve this purpose, we have three Glacier storage classes, the archival storage classes that customers use for these purposes. The first one is S3 Glacier Instant Retrieval that we launched last year. It allows for millisecond retrieval for data that is very rarely accessed, but needs to be accessed instantly when it is accessed. Second is S3 Glacier Flexible Retrieval. It has more flexible retrieval options ranging from like minutes to hours, but is available at a lower price point than GIR. And last, we have S3 Glacier Deep Archive, which is the cheapest storage option available with retrieval time that ranges in hours. And we are really happy to announce that Glacier now improves the restore throughput by up to 10x when you are retrieving large volumes of data. And this increased throughput applies to Amazon S3 Glacier Flexible Retrieval and Amazon S3 Glacier Deep Archive for standard and bulk retrieval. It is available at no additional cost. And with the higher restore throughput, applications can now process archive data at a very fast rate. It supports restore requests at 1000 TPS, which means millions to billions of restore requests take up to 90% less time to complete your overall jobs. And we built this because customers told us that they wanted high throughput for situations like large backup restores, storage audits, or like machine learning use cases where they want to access archival data to improve the outcomes. With that knowledge, let's dive into second use case. So in the current economic climate, let's say you are working for a financial services company that relies on stock market data, and the stock market is fluctuating, right? So your data science team now wants to access long-term archival data sets to train their machine learning model. So how can you provide quick and easy access to archival data to improve the results of your data science models? And we looked at the Glacier storage classes and the increase in throughput, but we also want to look at how you can restore your data at scale using S3 batch operations that we discovered in the previous case, and also see how we can automate the notification process of completion of restores through S3 event notifications. So like we discussed in the previous case, S3 batch operations automatically initiate requests, and now at a faster rate, allowing you to restore billions of objects containing petabytes of data with just a few clicks in the management console. And in this, you can achieve the retrieval of your data in 4 steps. So in the first step, you will choose your AWS region and the input file, which contains details about the objects that need to be restored from your Glacier Deep Archive storage class. In the second step, you will see a bunch of options available for your operations, but you will choose restore operation to restore your data from the Glacier Deep Archive. And finally, you can select restore configuration. There are 2 things that you'll need to configure. The first is the restore source, whether you are restoring from Glacier Flexible Retrieval or Glacier Deep Archive, or you're using Intelligent Tiering Deep Archive Access Tier or Archive Access Tier. Based on that, you can select one of those options. The second thing is you will have to choose whether you want to do a bulk retrieval or a standard retrieval based on the urgency of your business use case. And lastly, you can select any additional configurations and just create the job. Now, as the job runs, customers have told us that they want ways to see if the job has completed, and they want to be able to send that information to destinations like SQS, SNS, or trigger a Lambda job for that. And you can achieve that in 3 easy steps. So you will go to the properties tab for your bucket, for which you want to enable your event notifications. You will create an event notification, as you can see on the screen here. And then you can name the event configuration and select object restores there. And finally, you will have to select the destination where you want to send your information of completion of restores. It can be a Lambda function, an SNS topic, or an SQS queue. So that's how you have automated the process of restoring your Glacier objects at bulk with the batch operations process. And you've also set up event notifications to give you a notification at your destination when the restore process is complete. And with that, I'll now hand over to Rob to take us through the next 2 use cases.
All right. Thank you, Shaki. So we'll walk through 2 more use cases, a lot of additional tools and features to make you aware of. Shaki hinted at Storage Lens earlier. There's so much power and flexibility to Storage Lens. And actually, we just launched 34 new metrics for Storage Lens just a couple weeks ago. So we'll start there and outline a few of the other insights features as well as we talk about querying logs. With Storage Lens, the best way to think about this feature is it's designed to give you visibility all the way from the organization level down to the prefix level. So if you're trying to look at, like Shaki said earlier, which buckets have unencrypted objects, great place to start. Which buckets have all their data in S3 standard, it might be a good opportunity for cost optimization. Or if I'm going to save money on storage overall and look at opportunities for that, what are my top 3 buckets? What are my top buckets that are really driving that storage so you know where to focus your energy? So Storage Lens, 34 new metrics, look them up. It's a lot across lifecycle, replication, detailed error metrics, so many things. As we look at a few of the other features on this screen, Shaki talked about inventory earlier because it gave that object level metadata around each object. So intelligent tiering access tier, you turn on the intelligent tiering storage class and are curious about what's staying in the frequent access tier, what's moving to the infrequent access tier, and what's moving to archive instant access tier. Best place to look at that is in inventory reports. Most customers will see a lot of their data shift to those lower cost tiers over time. But if you're seeing a lot of access on an object, that's a great place to start and look at what's still in frequent access. Who's accessing that object? Why are they accessing it? All kinds of stuff we can look at here. Storage class analysis looks at the access patterns of data and then makes a recommendation around what lifecycle policies to write. So for a lot of you, you might have buckets with fairly predictable access patterns. You might hypothesize that people are accessing it for 2 days, 7 days, 14 days before the access really drops off. That feature is going to give you a visual representation of that. So showing the data in its first 0 to 15 days, how much data is being accessed. How does that change after 60 days, 90 days, a year? And just being able to visualize that and understand what's the right point to transition data to lower cost storage classes can be really valuable. CloudWatch metrics, we'll show a visual in a second, but there's a few different CloudWatch metrics you have available with S3, and you have the ability to alarm on them, especially things like the request level metrics. So there's daily storage metrics available in CloudWatch. Those are free, they're there. You can log into your console right now and look at those. That'll show storage and object count, and it'll show the storage by storage class. So you get some basic visibility there. But if you want to see things like minute-by-minute request level metrics, you'll turn those on for CloudWatch metrics. They're very low cost. Talk to a lot of customers about these. This session's all about scale. Some buckets, you have thousands of transactions per month. Some you might have millions and billions. Those metrics are just priced on per metric per month. So turn on the feature. It's just a few dollars per bucket to turn on all those metrics, and the metric only gets emitted when you have traffic that's applicable. So great feature to look at, and I'll show you a visual in a second. And then we're going to talk a bunch about logging in this session. So you've got server access logs. That's an S3 available feature. Set it up in a few clicks, store it in your S3 bucket. But you also have CloudTrail data events available. Management events, data events to log there as well. And when you have CloudTrail working for a lot of different AWS services, having that work across services can really be helpful. I promised some visuals. We'll have more later. But storage lens here, you can see just in a quick snapshot view, how much storage, object count, average object size, which, as you can imagine, might vary considerably between buckets. So here, my average object size is like 5 kilobytes. These are just mini objects that I dumped in this bucket. When you see average object size at the megabyte, gigabyte level, a lot more opportunity for savings and using some of the lower cost storage classes. On this next slide, we have a view of those request metrics. So these are minute-by-minute metrics. Here in the S3 console, I have it zoomed out to a 2-week view right now. But if you opened up CloudWatch, you can continue to adjust that view that you want to see and really see those patterns. For things like error rates on a bucket, 500 errors if you're seeing like a spike in a new workload and there's a lot of traffic to a bucket and it's still scaling up, you may see that very easily visually here. Things like error rates for object not found, access denied errors, seeing those on a graph and exactly when the problem happened is going to allow you to diagnose what deployment, what issue caused that. So these tools, really powerful. And as I mentioned, the CloudWatch request metrics, you could set up an alarm. So if we see error rates over a certain amount, let's page someone. Let's message someone. Let's get someone looking at this and not just notice it when our customers are telling us about it. And then storage class analysis. Here, there's just one visual of % of storage retrieved over a period of time. Kind of a curious access pattern on this one of my buckets. But this pattern and really seeing when's that percentage retrieval extremely low in a bucket, when's it a good opportunity to move it to lower cost, infrequent access, Glacier instant retrieval type storage classes. We talked about those options for logging. You've got one in S3. You've got one in CloudTrail. On the S3 side, server access logs. Fun fact, you don't pay for the request to write those logs to your S3 bucket. That's kind of a fun built-in feature. You just pay for the log storage. So S3, low-cost storage in the cloud, you store these logs. You could write them right away to a lower-cost storage class, or you could do something where you probably have them in standard for 30, 60 days, and then move them down after that. We'll talk plenty about lifecycle later. This is a space-delimited format, so it's just putting all the metadata around that particular event in one place. So it's written out with just a space delimiting it. So the query performance at millions and billions can be a little slower because of the format that's used here. But it is low cost. It's easy to set up. So definitely something to consider if you don't already have server access logs turned on. And it's any request to the bucket. So very easy to set up. And then you're going to see a lot of information populated there in a hurry. On the CloudTrail side, you've got management events, so things like bucket level activities. But you also have data events. So you can turn on data events. It's a JSON format, a bit easier to query. I'll show you an example of that in a second. And then you pay for the log storage and the amount of events delivered. And the integration part is exciting too, because you can forward it to CloudWatch events, CloudWatch logs, and I have a visual of how you can see the logs over time. You can see those spikes. You can see when activity might have changed in a bucket just by looking at the visual UI for that particular console. Here's a view of the data event format. So probably not something you're going to take detailed notes on, but just to give you an idea of that structured format, JSON, things you can access here. Account ID, I mean, looking at all the gets from a bucket and seeing the account ID those are all coming from, looking at source IP address. This is the kind of information you're going to have available in logs when somebody asks you a tough question about who's accessing this bucket, how's this bucket being used, do we have the right permissions set up, do we have too many permissions set up for this bucket and we should update it. Using logs to understand exactly who's using that data can be really helpful. On the server access log side, once again, rich data available. And a few I want to highlight in particular. Request ID is unique for all the requests to S3. They're making millions of them, billions of them, trillions of them. You'll have a unique request ID. So if somebody has an issue with a particular request, wants to dive into it, run a query, find that request ID in your logs, dive in further. HTTP status and error code. So querying by both of those. I talked about something like an access denied error, something like an object not found. If you're not seeing those on a regular basis, something's changed, you're starting to see those errors, let's look at all the requests that happen there. Are they in the same prefix? Are they in the same, is it just one object in the bucket that is seeing those errors? You'll be able to quickly write a SQL query. And I think Shaki showed it earlier with Athena. The ability to get up and running with Athena on top of these logs and then just start experimenting with SQL, I think for a lot of people in this audience, SQL is by no means intimidating for this technical group. So the sooner you can get SQL up and running, test it out, see what you can get quickly queried and find out the information, really helpful for all of us. And then total time and turnaround time, they're defined well in our documentation. But total time being Amazon receives the request and when's the last byte of the response sent back to you. So understanding that time may vary considerably based on object size, based on region of the world, based on other changes to the application. And then turnaround time, last part of the response, request received from S3, and then responding back to you. So how quickly are we getting the request from you and then getting you that first byte back? So both of those can be interesting to look at to understand how requests are being processed by the bucket. Here's our use case now as we dive in. Phone rings, colleague calling, might be a little bit frantic. We've got demos coming up. And when you have demos coming up and things aren't working, the stress level gets a little higher. They're asking for help in the moment. So they're looking for detailed error information because they feel like everything should be working, but they're running a query or they're running the application and they're getting something like a 403, a 404, and they're just not understanding what's going wrong. So how can we help them out? We've got the log saved. Let's query some information and help them out. We'll use CloudTrail data events in this case. The session's about working at scale, so we wanted to look at the one that's JSON format that should probably query a little bit faster for you. But certainly there are cost considerations, so happy to talk to folks afterwards on server access logs, CloudTrail data events, things to consider there. And then Amazon Athena, it really was just a few clicks in the console to walk through the Getting Started guide and to be querying the logs in my bucket. Some common log analyses as we talk through it. We've got a colleague here who has a specific question. So here, if they have a request ID, great, we'll just jump at that. But if they're just seeing a certain error message, OK, let's look at a window of time and that error message. But you could also look at things like a particular object that they're naming and saying, hey, it's this object in the bucket, what's going wrong? All those things will help you write the SQL query. Analyzing that request latency, both the total time and the turnaround time, can be good to look at there. Who's accessing data in the bucket? We saw that account ID field. There's a user agent field. There's the source IP. So you can look at all of those to understand, of all the requests over a period of time to a particular prefix, part of the bucket, who's using it. And then lastly, investigating access patterns in a bucket. So this can be helpful. We talked about some of those tools earlier to understand how frequently accesses data in a bucket. If you want to go down to the object level, you really want to understand who's accessing this part of the bucket, who's accessing this data. Logs are a great way to do that. So the log query approach here, as we go through, we'll watch the setup process. We're going to create a trail in CloudTrail. So we're going to say, we want data events turned on for this bucket. We want that object level activity. We'll specify where to store the logs. Then we'll enable CloudTrail data events. And we're going to turn it on, in this case, for all new and existing buckets. But you can filter that. You can say, this bucket, I only want this amount of events, because you can really filter it down. We'll set up the Athena table, and then we'll show some query examples. So here, we are going to set up the trail, creating a new S3 bucket, so it'll auto-populate that for you. And then you've got options for KMS encryption, log file validation, et cetera. So easy setup process, a lot of good helpful hints along the way as you're going through that. On the CloudTrail data event side, as I pointed at it, in this case, we're going to use the data event source as S3. You can also select DynamoDB there. You can select Lambda as well, so you have flexibility to see data event visibility, so kind of deeper into the service itself and do it on the data plane level. And then in this case, it's very easy to turn it on for write and read actions and for all new and existing buckets. So a lot of more things in S3 or in AWS in general, when they're built out this way and you know what you want it to apply to all other ones, why tell other teams to do it? Just set it up this way. Creating the table in Amazon Athena. This is a known format. It's a CloudTrail data event. It's all pre-populated for you. You're just clicking buttons. So all of this was auto-populated for me. Easy to set it up. Here we just started running a query just to make sure everything was up and running. Very simple to select the source of the data and then get running with that first query. And then at that point, you've got SQL. You've got all the flexibility in terms of tuning that query. For this first one here, the example I used was, OK, we've got this example data file txt. So what's the file that our colleague's having trouble with? Let's look at all the logs related to that. You can narrow down the time frame. Potentially, you don't have a lot of logs, so that may or may not matter. But in this case, we just want to understand everything that's happening on that file. What are the errors we're seeing, and why? On this next one here, some might be familiar with SIG v2 versus SIG v4. This is just another example. So pulling a real-world example from customers that have the question, what's still using SIG v2? How do I find that out? What applications are using it? Where do I need to update it? It's a SQL query. It's a simple query. Run on your logs. And that'll get you quick answers. And then here, you've just got an easy visual representation of what's being returned back to you. So at this point, it's columnar. Maybe it's a lot of data where you have to continue to use AWS tools to do it. Or if it's small enough, you just dump it in Excel, kind of use it that way, send it to your colleague, et cetera. So very simple once you've got the queries done to then use that data. And here, I talked about that visual earlier, just seeing visually the activity in a bucket over time by saying, OK, I'll just connect CloudTrail data events to the CloudWatch Logs Insights view. And here, you can see those spikes in traffic. You can see the potential seasonality over long periods of time, or just the day-to-day cycles of how a bucket's being used. Next one, always a hot topic for customers, managing storage spend. So we've got a number of tools here. I'll even recap some of the launches from Lifecycle. Did a few launches last year. Some of you might have heard about them at reInvent, but they're so powerful that I really wanted to highlight them in slides by themselves. So preview for you, Lifecycle object size filter, and then Lifecycle setting the number of versions you want to retain for an object. Both extremely powerful features to be able to help you save money and save money that much easier. So you don't have to select exactly which objects you want to move, but you'll be able to set up a filter and get the most bang for your buck right off the bat. So right here, if there is anyone who's not familiar with Lifecycle, I'll go through this very quickly. But you can transition and expire data using Lifecycle. Common pattern is to ingest most of your data to standard. I think more and more customers are using intelligent tiering for that. But if your data is starting in standard, for example, there's just a lot of opportunity for savings. Shockey brought up that picture of the different storage classes earlier, talking about Glacier Instant Retrieval, Flexible Retrieval, and then Deep Archive. You've got just such a wide selection of storage classes, whether it's standard and intelligent tiering, the infrequent access storage classes, and then Glacier. So being able to move data, and we've got a number of arrows here to show it visually, but moving data from standard. You can even move from standard and frequent access and save more. You've got intelligent tiering, one zone infrequent access, Glacier Instant Retrieval, and Glacier Flexible Retrieval. Lifecycle can manage all those transitions for you, and you can set up rules. It's automatic. It's one less thing for you to think about. Here's a very simple example here. So the data lands in standard. I see an access pattern where people are accessing it for 3, 4 weeks, something like that, where you've got a fairly predictable access pattern. Great. After 30 days, let's move it to standard infrequent access. At that point, you're saving about a cent per gig per month, depending on what region you're looking at. So significant storage savings, about 40% or so based on the pricing of S3. And then after a year, I want to move that data to Glacier Deep Archive. So understanding your access patterns, understanding how quickly people need that data back, if they can handle waiting a few hours to get the data back because it's so rare to need that data, let's move it to Glacier Deep Archive. Now you're saving potentially 95% off the cost of standard or more. So kind of making you aware of some of those eye-popping numbers and what you can get from using all the different S3 storage classes. When we look at a lifecycle configuration, Shaki showed some examples earlier. I mean, naming a rule, what you intended to do, what it's about, can be so much easier to go back and audit after the fact. You can set up to 1,000 rules for lifecycle on a particular bucket. So understanding who created it, where it came from, what's it meant to be doing, that can be really helpful. So just give it an ID, give it a name that's obvious. That's definitely my recommendation here. You can filter it. So if you put a filter, you can narrow it down to all the objects with a certain tag on them, a particular prefix within the bucket. So I only want to apply to this data. Or you can apply to the whole bucket. So there's a lot of things in the console if you're using Lifecycle where it'll really ask you, are you sure you want this rule to apply to the whole bucket? For transitions, that's something that generally you might want the whole bucket to move. But for something like an expiration action, making sure those filters are correct, making sure you really check that along the way when setting up these rules, test it on a smaller data set, test it in a different bucket. That's certainly our recommendation for customers. Status enabled, disabled, so you can turn off a rule but leave it here and turn it on later. That's an easy option for you. And then you get into what I find, I look at this a lot, but just something where understanding these rules, we'll go through examples later on, but OK, how many days and where am I moving it to in terms of storage class? So transition actions, expiration actions. Pretty simple to walk through that, but want to make sure you're aware of lifecycle and all the different functionality you've got. Lifecycle really goes hand in hand with versioning. So versioning, for those that aren't familiar with it, if you're overwriting data and versioning is not turned on in S3, you're using the same key name, we're just going to overwrite that object. You could do that all day, and at the end of it, you'll have one object. You turn on versioning because you want to maintain that version history. You might have people making changes to the objects, or you don't know if all your key names are unique, and you just want to make sure you don't accidentally overwrite something. Turn on versioning. So it creates new versions of the bucket. It'll maintain that first version. It'll create additional versions of the object. Great benefits there from a data protection standpoint, but as you're probably thinking, this is the managing storage spend section, and we're talking about maintaining all these versions. They will add up. If you're constantly overwriting an object, it could be thousands, millions of versions over time. So there's usually a retention policy that's going to make sense for your company, and it's probably not to retain them all forever. So just something to think about as you turn on versioning. It provides some delete protection, because if you specify a delete on that object and don't specify a version ID, we just add a delete marker. So now I've got photo.jpg that has a delete marker on it. So to the end user, it's going to look like that file's gone. But you as the admin, somebody managing the data, you go into that bucket, you try to read the old version, it's still there in the bucket. So if no one's deleted that specific version, if there's no lifecycle policy cleaning it up, you can go back. You can roll back that change. So it does provide that protection. If you do want to delete a version of an object, specifically, add the version ID, it will delete that object. So you have the flexibility to issue deletes that you want them to be soft deletes, so to speak, and have permanent deletes as well. Best practice here I wrote on the bottom is consider a lifecycle policy for all version buckets. Because of those versions building up over time, if you have enough versions in your bucket and you're trying to query or use lists to identify the versions in your bucket, identify the current versions, the more things there are in your bucket, it can affect that performance. It'll just take longer to go through the whole bucket. So there are performance considerations here as well, and you're going to save some money. So we'll talk about current version policies. That's the latest version of every object in the bucket. How do I want to deal with that? Do I want to transition it, expire it, et cetera? Non-current versions are all those overwritten copies. So it was in the bucket, it got overwritten, or it has a delete marker on top of it. Now it's a non-current version. Expired object delete marker rule, we talked about adding those delete markers. If all the data is gone underneath it, you've just got a bunch of delete markers in the bucket. And typically, they're not of a whole lot of use to you after the object's been gone, so you can set up a policy to delete those after a certain number of days. Can be good to have that marker that there was data once there, but after a period of time, they're probably not helping you anymore, and it just cleans up the bucket, less things to manage. And then incomplete multi-part upload retention, a good one to think about. Storage Lens shows this really well. Hey, you have this much gigabytes, terabytes, maybe megabytes of incomplete multi-part uploads. So somebody was uploading an image, a video file, something larger to S3, and the client disconnected, or the user decided to retry and refresh the page. If you've got these partial versions of objects that are sitting in the bucket, but they were never completed as objects, Set up a rule, delete them after 7 days, 14 days, find the right number that makes sense for you. If you have end users that might be uploading for weeks to finalize an object, it might need a longer time. But typically, if you're not finishing an upload within minutes or hours, it's probably not going to happen. So that's something you can look at it in Storage Lens, see where the multi-part uploads are being retained, the ones that haven't been completed. Set up a rule, delete them, save yourself some money. All right, so now we've arrived at use case 4. Email from an analyst on the finance team. They're in the meeting. You're not in the meeting, so you're just getting this secondhand. A meeting underway, lots of questions about spending. Why did we see this month-over-month change? And why did our storage spend rise 15% last month in our testing account? We've got a testing account. For years, it was pretty steady. We're probably deleting things after we use them and test them, but why did we see such a rise the last month? Let's dive in. Let's use Storage Lens. Let's use Lifecycle. Let's figure this thing out. So Storage Lens here pulled up one of the visuals. We looked at that high-level view earlier, but now as we look a little deeper, OK, where's the data? Like, what region should I even focus on? And here you've got data in Northern Virginia, Oregon, and then it starts getting a bit smaller from there. All right, so let's focus there. And what are my top buckets? So looking at my top buckets, we've actually got a few drivers here. This isn't a large bucket by any means. We've probably got some petabyte-sized customers in the audience. I'm a very humble bucket here. So looking at the percentage change, seeing about a 15% change month over month in the data stored in that bucket. Let's dive in further. And we've got the tools that now we're going step by step and looking at this bucket. The thing that we saw next is looking once again in Storage Lens, clicking on that data protection tab. So we talked about versioning has data protection benefits. Click on that tab and dive in. 64% of our bucket is not current versions. So not the newest data in the bucket, but things that have been overwritten, things that have been deleted, and they're just sitting in the bucket. There's probably an opportunity for some savings here. So let's think about retention. What's the right time period for retention? Should I retain overwritten data, and for how long? And should I have different rules based on object size? I want to make you aware of that feature, so we'll show an example later on. But now that I'm seeing 64% as non-current versions, it feels like there's an opportunity here. So we've got a few different examples. This is an unversioned bucket, so take away the current, non-current version for a second. Here we're going to transition data after a year to Glacier Flexible Retrieval. As Shockey said, you can get data back in minutes or hours from that storage class, plenty of flexibility, and it's after a year. Like, are we going to see that much access on it? Maybe, maybe not. Depends on the application, depends on the company. And then after 10 years, let's expire it. So this is an unversioned bucket, simple lifecycle rule, sits in standard or whatever storage class for a year, moves to Glacier Flexible Retrieval, and then after 10 years, it's expired. So now you've got a lifecycle set up for that bucket, one less thing to think about. On the version bucket side, we're looking at our transition policy. So transition, and this is our current versions because it's right here at the top. Transition after 30 days to standard infrequent access. Talked about, it's about 40% savings typically, about 1 cent per gig per month. Transition to standard infrequent access after 30 days, and that's if it stays a current version. If it's overwritten and now it's a non-current version, it's going to follow these rules. Fun fact, the non-current version timer is based on when it became non-current. So when my object is overwritten, that's when the timer starts. It's not from when the object was put in the bucket. It's from when the overwrite happened or the deletion happened. So here we've got a transition. After 7 days after it was overwritten or deleted, we're going to move it to Glacier Flexible Retrieval again. And we've got the ability to customize how many versions to retain. So I am going to move it to Glacier Flexible Retrieval, save some money if it's going to be retained. But after I have more than 5 versions, I want to get rid of those older versions. So if there's more than 5 newer versions of the object, and it's over a year since it's been non-current, let's delete it. So this just gives you an idea of the policies you can write, make sure it makes sense for your business, sense for the application, talk to the application owners, et cetera. But knowing you have that feature available gives you that control over count of versions, how much rollback you really want to be able to do. Here we're going to talk about that object size filter. So here I'm only going to be transitioning the objects that are over 128 kilobytes. So this is just a byte field, so you got to do a little bit of math here. But taking it by the power of 2 and multiplying it that way, you get this number. You want to move those larger objects because you're paying less to transition them in terms of transition costs, and you're probably moving the bulk of your data. So you're going to get the benefits of savings, but not moving a bunch of tiny objects that aren't going to save you much money anyway. So this is a pretty drastic example. Told you about my buckets earlier. I applied this non-current version policy. So many things were just non-current versions that were written over and over again. That 64% is probably undercounting for this particular bucket. This bucket was probably 90% plus that was non-current version. You apply that policy, you see pretty dramatic savings. So here, I had no qualms applying this policy to this bucket, but talk to your teams, talk about the data and what makes sense, count of versions, object size, et cetera. And you can see how significant the savings can potentially be. Now we'll welcome Robin up from Bridgewater Associates, who's going to talk about how they use AWS and some of the latest features from S3 to power their economic models. Thanks, Robin.
Thank you, Rob. Excited to be here. My name is Robin Anil. I'm the Director of Research Technology at Bridgewater Associates. We are a 45-year-old company. We are a global macroeconomic investment manager. And we have this notion that we endlessly pursue the right answer to how the economies work. Right? Our founder, Ray Dalio, wrote a couple of books about how economies work, pretty famous. And our model of the economy is pretty complex. It's like we try to understand these cause-effect relationships, and it's been evolving for the last 45 years. And the work that we do in our company is called economic research. And the research that we do, we call that timeless and universal, which means that it stands the test of time. For example, in the current market, you know there's inflation. And we know that the interest rates are going up. Why? The interest rates are going up because we want people to borrow less. And these kind of rules, we have understood how the mechanisms of the economy work over time. And this is a good video Ray has made about how the economic machine works. It's available on YouTube. I highly, highly recommend you watching this. So at Bridgewater, we take this model of the economy and we write that as code. And we run this model every day. For us, that model of the economy is like millions of lines of code. And it's broken up into several what we call mini models. Every day, a new data point appears. And every day, we have to figure out that the model still works. We apply the new data against our existing understanding of the economy. We call that forward testing of the model. We also back test changes. For example, when we think about new ideas on how, maybe we need to tweak the model slightly, we need to make sure that our model still behaves correctly back in time when recessions happen in 2008 period or things that happened before. We need to really back test and make sure things really work. We also do a modeling what we call what-if scenarios. And what-if scenarios are really trying to understand, hey, if the war in Ukraine stops, what happens? Right? We need to really understand those hypothetical scenarios. So we run those as code, as models in our system. Along with all this, we have to do one more thing, which is we have to operate in markets and trade in markets because that's how we make money. So we have a production version of the system that is running the production quality version of the model every day again. Now, AWS-based architecture allows us to do this reliable scale-out of our infrastructure and of our models. To give you a 50,000-foot overview of how this architecture works, we broadly think of our architecture as 3 buckets. One, a compute grid, a data lake, which is made of S3, and a reporting and analytics system. The user, in our case, is an economic researcher. They're building a model. They write that in code. It's a proprietary language we built on top of Scala. They submit that code to the compute leader, which takes that code, compiles it in the build worker, sends that over to the worker pods to run that at scale. It is based on Amazon EMR and EKS. All the intermediate data during that simulation or modeling, we write that into EFS. But the key part is our storage system. All of our inputs, going back centuries of data, is there in our data lake. We use and store data on Amazon S3. We use Amazon DynamoDB to store all the metadata. And then we use the Amazon Elasticache for Redis to accelerate some of the read workloads. This whole storage system is our data lakes, which is used by our reporting and analytics applications, which are these visualization and reporting applications that we built on top of Amazon EKS. We've recently launched an analytics product on top of Amazon EMR Presto, which directly accesses the data in Amazon S3 and produces insights for our economic researchers. At Bridgewater, if you think about like the data storage needs, we think of in certain lenses. First lens, of course, for us is security. Security is paramount. For us, it's important that even the models are isolated from each other, right? We want to make sure that different researchers don't know how they're working on each other. We do some siloing in our company, and that's very important from how we operate because we manage billions of dollars, and we want to make sure that access is tightly controlled. We also care about reliability because we are operating and trading in markets. Every moment we are not trading, we may be losing money. Finally, last but not least, it's a cost. We need to make sure while we do all these things, while we make sure our data lake grows, we need to keep the cost in control. But at the end of the day, our users, which are the economic researchers, they care about scale. They want to build new complex models, understanding of the economy, use new forms of data, scale it out, and run this and get their insights. So like I said, we built our proprietary database on top of Amazon S3 as a data store. Our files under the hood, we use columnar formats. Amazon DynamoDB is our metadata store, and Elasticache is our accelerator. If you look at some of the features that we've used, especially coming from Rob's and Shaki's demos, you saw we use the Amazon customer-managed Amazon AWS KMS encryption. We use a default encryption for Amazon S3. We also use S3 object lock. We never delete any data. It's very important for us at Bridgewater to never delete data because we want to go back in time and look at our decisions. We want to know how we were wrong. We also want to know how we were right. So we want to make sure that all the decisions are never deleted and we can go back and inspect them. We have controls to ensure security and compliance as we scale to tens of petabytes of data at Bridgewater. On the topic of reliability and consistency at scale, we use a lot of features, again, from S3, including the replication time control with the cross-region replication. We have started using the consistent reads in S3 solution. This went beyond read after write. It's one of the close collaborations we worked hard with the S3 team. We also use the S3 storage lens for analytics because we have a huge data lake and we need to know what's happening. And we've started using the S3 multi-region access points recently to get that cross-region reliability. So our system is designed for full region outage scenarios because we want to make sure our business continues to operate. So to give you a little bit of an interesting problem that we have, we care about consistency not just at a single file level, because when we run an economic model, we're creating a sets of file. We call it that like a data set, which includes like n files that the model generates, along with what we call as a commit or metadata file that we also write that points to those n files. So for us, we need to make sure there's an all or nothing on that entire data set. Especially when we go across regions, we want to make sure that from region 1 to region 2, the entire data set is available. To do this, we use the replication time control hooks to understand the latest timestamp of the commit because we ensure that the commit is finally written as a transactional way. And then we try to replicate it across 2 regions, and we check the second region. The SLA we get from replication time control is 15 minutes, but we typically see the data is replicated in 1 to 2 minutes. And this is great for us because in case we have a region loss, our data is only lost by in the last 3 minutes, and we can recompute it because we can rerun the compute models. This is excellent for us. And on the topic of costs, lifecycle we talked about, it was so easy for us to enable S3 intelligent tiering. And this year, we went down almost like 35% in cost, while our storage is actually up year over year, 42%. So thank you, S3 team, for that. It was very easy. Just to give you a summary of the size at which we operate, for my team alone, this is just the research technology and there are other teams, we run at 20 petabyte scale S3 with about 120 billion objects, growing about 2 petabytes a year. So to keep all this in control, we are really grateful for the S3 team to build us these amazing features so that we can manage this at scale. this year, I want to really thank the AWS team overall, because through the partnership, we have had almost 2x reduction in our average runtime of our models through the various projects that we work with them, increased the machine utilization. And this is most important for us, because we have unlocked some frontier research. We could take our biggest models and scale that up 5x. And that's been unlocking for us. So thank you, Rob, and thank you for giving me the opportunity here to tell our story.
Great. Thank you, Robin. And with that, we'll recap. We talked about encrypting objects at scale, then restoring data from Glacier, once again, at millions and billions of object scale, querying request logs, where you've got multiple choices there for data level activity, configuring your retention policies using a lifecycle, using things like Storage Lens to get visibility. And then thank you, Robin, again, from Bridgewater Associates. Cutting edge features he's using, multi-region access points, things like intelligent tiering, the amount of savings he saw, KMS encryption. You've got a lot of examples now of how customers are using this today. You can continue your training beyond this session, earn storage badges, go and ramp up on additional knowledge around S3 and other storage products with the easy link there. So make sure you grab that one. And then last but not least, please fill out the survey. It really helps, and thank you all for joining us today.